guys, in this video we're going to do some factoring review. So these are skills that you've learned in Algebra 1 and hopefully practiced a little bit as well in geometry. But basically we're just going to do a little bit of review and practice with factoring because we're going to be using this later on to solve quadratics. So for this first day of review, we're just going to look at a couple different techniques of factoring. The first one is what we just call the GCF, and this actually applies all the time. So GCF stands for greatest common factor. So we're looking at what factor, which means what component of a term can I divide out. So if I look at this expression, they both have a b in common, so I can divide out the b. So what this means is the b is going to come out front. What I have left is an a minus c. So this would be factored. So factoring is the opposite of distributing. Okay, and so if I were to distribute the b back, I would end up where I started. So this is considered factored, this is considered expanded, okay? All right, so here, if I look at all three terms, so I can take out a -3. A -3 goes into all three of those terms, okay? I also have a b squared, and a b to the third. So the smallest one there is a b. Okay, so what I have left after I took out -3b is I have 1b squared. We started with 3 b's, but I took out a b. I took out a -3, so this becomes a positive 2b. Took out a -3, so that's going to be a -3. Okay, so this is factored. Okay, next we're going to look at, so notice I had a bunch of different terms here. Oh, sorry, I have one more. So this right here is a term. So a term is tied together with multiplication, okay? So I'm looking at what factor do the terms have in common. So I have this piece and this piece. So my GCF is a plus b. Okay, so they both have that in common. So I'm going to pull that out front, divide that out. Okay, and what's left is x minus y. Okay, so that is what this looks like. I can have a GCF that's more than just one component. It could have addition and subtraction involved in it as well. Okay, next one we're going to look at is something that has 4 terms, and it's actually going to look a lot like this last one. So what I'm going to do, grouping, this is 4 terms. So there's 1, 2, 3, 4 terms. So terms are separated by addition and subtraction. Is I'm going to do 2 at a time. Okay, so I'm going to look at these first 2 and look at what is the GCF for those first 2 terms. So for this first 2, it's 2x squared. Okay, what would be left after I divided out the 2 and the x squared would be 6x plus 1. Whatever sign is here, you're just going to bring down. So this means I'm going to factor out something negative. So now I'm looking at -30x and -5. I can take out a -5 from both of those terms. So what would be left is a positive 6x plus 1. And if you are doing this method correctly, we should get another GCF of 6x plus 1. Now this looks a lot like this example we did up here. 6x plus 1 is another GCF I could take out. So that's going to go in front. And then what would be left is these pieces here. 2x squared minus 5. So this would be completely factored. Okay, let's try this one. So 4 terms, I'm going to do 2 at a time. Okay, from this term I can factor out a 2x squared. What would be left is x minus 5. Plus sign, just bring that down. Okay, so I'm factoring out something positive. I can take a 3 out of both those terms. Dividing out a 3 leaves me with x minus 5. Again, those match. Pull that out front. That's the next GCF. What would be left is 2x squared plus 3. Okay, a couple more like that. Another 4 term. Okay, something else that we should look at too, you guys. I guess I'll look at it more in the next one, but it's a good idea to ask yourself, is there a GCF I can take out of everything first? So if I look at this one, I was kind of saying, oh, they might divide by 4, but 4 doesn't go into 7. I might be able to take an m, but this one doesn't have an m, so I'm going to proceed. Okay, so from this one, I can take out a GCF of 4m. So what would be left is 4n minus m. Okay, out of these two, bring down my plus sign. I can factor out a 7. So we're going to have 7 times 4n minus m. Again, I got another GCF, 4n minus m times 4m plus n. All right, this one, is there a GCF I can take out of everything first? So number-wise, I don't believe there is. Y's? U's? Oh, maybe not. Okay, so now I'm going to just jump in. I can take out a 3x squared. So I would be left with 4u plus v. Bring down my plus sign. Here I can take out a 7y, and we'd be left with 4u plus v. And again, those match, so I can pull that GCF out. 4u plus v times 3x squared plus 7y. All right, so grouping is what I can use anytime I have 4 terms. Okay, now we're going to look at a trinomial, which is a 3-term expression. You'll notice I do have one down here that's a binomial. It's just 2 terms, and we'll talk about that when we get to it. But every single time I have 1x squared. So this is what this means by a equals 1. We have been working with quadratics of this form. And so this is what it's talking about. Trinomials when a is 1. It's saying that number in front of x squared is 1. So this strategy we can use anytime we have 3 terms and my number in front of x squared is 1, my leading coefficient. Okay, so what I'm looking for here is this is going to factor into 2 groups. Whatever the variable is, it's going to go here and here. And I'm going to fill this with 2 numbers. So how I get the numbers is it must multiply to be c, so must multiply to be 6, and add to be b. So multiply to be 6, add to be 5. So those 2 numbers would be positive 2 and positive 3. They multiply to be 6 and add to be 5. Okay, so this is the answer. Okay, but I want to show you why it works. Like, why is that factored? So if I were to distribute x times x, x squared, x times 3, 3x, 2 times x, 2 times 3. So that gets me back to here. So this is the opposite of that distributing. So this is factored. Okay, so that's my answer, but that's kind of a check to see why it works. So it does get me back to my trinomial I started with. Okay, let's try this one. So this time again, I have a trinomial with 1 in front of x squared. Okay, I need numbers that multiply to be 20, that add to be 9. That would be 4 and 5. Okay, this time I've got a negative involved, so I need them to multiply to be positive 12 and add up to be negative 8. So to multiply to be a positive and add to be a negative, I'm going to need 2 negatives. So negative 2 and negative 6. They multiply to be positive 12, but add up to be negative 8. Okay, numbers that multiply to be negative 28 and add up to be negative 3. So one of these is going to be negative, one's going to be positive for that to happen. So I need them to multiply to be negative 28 and add to be negative 3. So that's going to be negative 7 and positive 4. Okay. All right. This one, I need them to multiply to be negative 14 and add up to be positive 5. So that would be positive 7 and negative 2. Okay, and this one, you're like, wait a second, this is not a trinomial, it's only 2 terms. This actually could be written as a trinomial, x squared plus 0x minus 9. So I'm doing the same thing. I want numbers that multiply to be negative 9 that add up to be 0. So numbers that multiply to be negative 9 that add up to be 0 would be a positive 3 and a negative 3. So we can actually do some binomials. Now, if I wasn't able to come up with 2 numbers that multiply to be c that add up to be 0, then I just can't factor it. But this one, we can expand and just write that b term as 0. And then if it factors, we can do that extra step. Okay, that is it for our factoring review day 1. Thanks for watching.